Good day! So this is our last week for the third quarter and yung lesson natin ay applications ng exponential and logarithmic functions. And we'll start with the idea of interest and interest rates and expand that to what we would call compound interest. You'll probably encounter interest rates when we talk about loans kasi pag uutang ka, especially kung sa bangko, meron siyang interest. Meaning, yung uutangin mo, mas malaki ibabalik mo. Kasi that's how banks earn money from loans. Now, saan sila kukuha ng pang-loan nila? Siyempre, kailangan nilang pera. That's why they offer savings accounts or investments. So, hahawakan nila yung pera mo para maipapautang nila sa iba. Pero bakit ka naman magbibigay ng pera sa bangko? So, they have to give something to you to make it worth your while to give your money to them. So, this could be in the form of savings accounts para meron kang paglalagay ng pera na sure kang hindi siya mawawala, protected siya by insurance, and at the same time, may konti silang binibigay sa'yo for the privilege of holding your money. So, ito rin yung interest rates ng ating mga savings accounts. Now, in general, when you have an interest rate na ibibigay sa inyo, na ipapublish ng isang institution na legit, these are rates for one whole year. And what I did was I searched for supposedly the highest interests sa mga savings accounts in the Philippines na available for us. And I got this from pesolab.com. I'm not sure if that site is legit though. So, for our purposes, sige, pretend natin. And kung titingnan natin, medyo mabababa sila, no? And most of the best high-interest accounts, they're less than 1%. So, kung titingnan natin, ano lang ba yung 1% or higher na accounts? You'll have the Sterling Bank of Asia na pang OFW. I'm not familiar with Security Bank e-Secure Savings Account. It's the first time I've seen that. And sa Citibank. Pero kung tignan natin, yung pinakamataas, yung ING at 4%, pero meron siyang asterisk. Bakit siya may asterisk? Kasi may conditions pa yan na may kailangan ma-meet, plus hindi yata yan forever na interest account. Like, it's a promo interest rate. Same with yung G-Save ng CIMB. So, kung meron kayong GCash, meron siyang option doon na parang G-Savings or GCash Savings. Tapos, actually, pag nagsisave ka doon sa GCash, napupunta yon sa isang account sa CIMB, which is, if I'm not mistaken, a Malaysian bank. And they offer this relatively high na interest rate. So, that's actually a good place to save money habang nagsisimula tayong mag-ipon. Of course, when you have more money, you'll be able to have more options kung saan mo siya pwedeng ilagay where it could earn more. But in general kasi, when you go beyond savings accounts, yung rules on how these investments, or sometimes we call them instruments, earn money, hindi na kasing simple nung i-discuss natin ngayon. Pwede na siyang mag-fluctuate, pwede siyang nakatali sa price ng petroleum or gold in the market, pwede siyang nakatali sa prices ng stocks sa isang company. So, for our lesson, kukunin lang natin yung pinaka-basic na investment or na way na mag-i-increase yung value nung pera natin, na investments natin, which is through a guaranteed interest rate. For the sake of computation, we might be looking at examples na medyo hindi realistic yung interest rate. In fact, anything higher than 4-5%, it may not be a realistic option for a lot of us. Although, may certain groups of people na may access to higher interest percentages, but in general, yung available sa general public, sa mga usual na banks, matataas na yung mga interest rates na nasa chart na to. Okay, so let's start. Let's start with simple interest before we go dun sa actual lesson natin. So the idea of a simple interest is, pupunta ka sa isang bangko or institution na nag-o-offer ng simple interest. Magpapasok ka ng pera, and we call that principal. Kaya tayo may letter P dun sa mga equations natin. Principal. Yun yung initial na perang ilalagay mo. Tapos meron siyang corresponding na interest rate na ino-offer. So in this case, the interest rate is 3.875%, let's say. And what happens is, after a certain amount of time, let's say 1 year, bibigyan ka nung bangko nung interest on your principal. So the total amount, yun yung A, at the beginning sa year 0 is yung kung ano lang yung principal mo. After 1 year, ang total amount mo is, syempre, andun pa rin yung principal mo, plus yung interest na na-generate ng principal. So let's say the interest here is 3.875%, makakakuha ka ng 1 million times 3.875%, which is 38,750. So the amount of money that you have at the end of 1 year is 1,038,750. Ang ginawa sa account na to, winidraw agad yung 38,750. So at the next interest giving period, mabibigyan na naman siya ng 38,750. So ano yung total amount meron siya? Meron siyang 1 million, yung 38,750 na una, tapos yung 38,750 na pangalawa. So in simple interest, ang nag-earn lang ng interest yung principal. So every year, ang nadadagdag lang sa'yo ay 3.875% nung 1 million. This is not how banks usually work. Nag-work lang siya for this case kasi wini-withdraw agad yung pera na na-earn sa interest. In general, sa isang bangko, yung interest na ina-earn mo after year 1, pagpasok niya ng year 2, it becomes sort of part of the principal and it starts to earn interest on its own. So nagkakaroon ng interest yung interest. Let me visualize, or let me help you visualize this. No? Now, this form of interest generation, na yung interest na ina-earn, next year mag-earn na rin siya ng interest, ang tawag natin sa kanya ay compound interest. Kasi parang nagko-compound yung interest on top of itself. So let's say, sa start, year 0, nagpasok ka ng pera, yun yung principal natin. Now, at the end of the first year, of course, you still have your principal, but on top of that principal, you'll also get some amount of money that is yung interest na na-earn nung principal mo. So let's say this is, I don't know, 25%. So you get the original plus 25% of your principal. So, ito na ngayon yung total amount of money mo at the end of 1 year. After another year, at the end of the second year, of course, you will still have yung principal mo, tsaka yung interest na na-earn at the end of year 1. But bukod dun, nag-earn na naman yung principal mo ng another 25%. Tapos yung una mong interest na na-earn, nag-earn din siya ng 25% naman niya. So mas malaki na yung pumasok na additional amount sa'yo at the end of the second year. So parang mas malaki yung na-earn as the number or as the amount of time increases. At the end of the third year, you still have all of these amounts and then 25% na na-earn ng principal, 25% na na-earn nung una mong interest, 25% na na-earn nung pangalawang interest, 25% na na-earn yung interest ng interest, and that's what you have at the end of the third year. Now notice how it works is that parang may fraction nung original, nung naunang blue, yung ma-earn mo sa next round. So this is 25% of this. This is 25% of this. Kaya para similar yung shapes nila. Proportional sila, yung blue tsaka yung green. And this is 25% of this. Proportional din yung shapes. Now, if we are to put this down using equations or formulas, yung total amount mo at the start, year 0, is your principal. Yung total amount mo at the end of the first year is your principal times 1 plus R. Bakit may 1? Kasi syempre andun pa rin yung original amount mo eh. So this is the original amount plus yung percentage nung principal. So R times P. At your second year, parang si A1 mo na yung bago mong principal at imumultiply mo siya ng 1 plus R. So, A1 times 1 plus R, that's just the same as P times 1 plus R squared. And when you get to the third year, parang ito yung buong principal mo, mumultiply mo siya ng 1 plus R, and you get P times 1 plus R cubed. Generalizing that, I think we can see that the total amount at the end of t years will be the principal times 1 plus r raised to t, where t is the number of years. So let's proceed to our first example. So what I did, nirecord ko to separate from this set. So baka mag-iba yung volume or yung speed ko na magsasalita. Our first example is as follows. 10,000 pesos is invested at an interest rate of 7% per annum. And we want to compute for the amount of money that we'll have, the total amount of money that we'll have in 6 years. Let's proceed. Balik tayo sa formula natin na total amount sa function of time is the principal times the quantity 1 plus r raised to t years. And the total amount in 6 years is equal to the principal times 1 plus the rate. The rate is 0.07, 7%. T years. Actually, I should have used t equals 6 na dito. But substituting our values, we'll have 10,000 times 1.07 raised to 6. So we'll just evaluate this. This is approximately 15,007 pesos and 30 centavos. So if the interest rate is 7% per annum, tapos kino-compound siya at the end of every year, after 6 years, yung 10,000 natin, we'll expect that to be around 15,007 pesos. Note that yung 7% per annum, medyo hindi siya realistic. Ano lang siya for our example. But this is a pretty high interest rate and it's highly unlikely na ibibigay siya sa atin. At the same time, pag kumukuha tayo ng loans, pag kumukuha tayo ng mga utang, sobrang mas malaki pa sa 7% yung mga interest rates na binibigay sa atin. They could be as high as 20% per annum. Okay, I hope the transition was seamless. Now, in reality, hindi necessarily 1 year yung kailangan mong hintayin bago mag-earn ng interest yung pera mo. There are different compounding periods and one of the most common is yung quarterly compounding. What does this mean? Meron kang annual rate, like say 7%. Yun yata yung nasa example kanina. So, dun sa example natin, you have to wait till the end of 1 year before dadagdagan ng 7% yung pera mo. What is usually offered is that you earn money after a set amount of time. So, pwedeng in 1 year, your savings account mag-earn siya 4 times or quarterly. And what happens is, yung sasabihin sa'yo na interest rate for the year, de-divide yun kung ilang compounding periods yung meron. So, for a quarterly, that's 4 times. You earn 1/4 of 7% every 4 months. Pero, yung ma-earn mo na 1/4 of 7% on the first quarter, mag-earn na ulit siya ng interest sa second quarter. So, it could be a bit better kasi mas mabilis nagkakaroon ka ng interest kahit konti, tapos yung konting interest na yun, mag-earn din siya ng konti. So, this is a screenshot from a Metrobank savings account. I don't know kung nakikita nyo may nakalagay may Metrobank doon. Na ang interest rate ay 0.125%. So this is 1/4 of 1%, no? Medyo maliit talaga siya. So you can see that kung ito yung pera sa simula, nag-earn siya ng 329 nung December. Itong 0.49 tax yan. Kasi mag-earn ka na nga lang ng interest na 1/4 of 1%, itatax pa yan ng gobyerno. So, nag-earn siya ng interest ng December, nag-earn siya ng interest ng March, after 3 months, nag-earn siya ng interest ng June, after another 3 months. So, this is a quarterly compounding example. Kung meron naman kayong savings account sa BDO na I think yung parang junior savers, so this is from a junior savers account. This one compounds monthly. So ito yung initial na amount, mag-earn siya ng 2 pesos 48 centavos ng July. May tax pa rin siyang 50 centavos. As by August, meron na naman siyang interest. By September, meron ulit siyang interest. October and November. So this one compounds monthly at yung interest rate niya, which is yung interest rate for the year, is 1/4%. Tapos divide mo pa siya by 12. Yun yung ma-earn mo every month. So may ganun na compounding. Usually, you don't get semi-annually and you don't get weekly. But we might look at those examples for the sake of understanding yung mathematical principle behind it. But if you're looking for savings accounts na nag-exist talaga, usually you get these two, quarterly and monthly compounding periods. So let's proceed to generalizing yung compound interest formula. So we saw that we expanded on the total amount is equal to the principal times 1 plus r raised to t by dividing the interest rate by n, kasi may n compounding period sa hatiin yung interest rate na binigay sa atin. At the same time, yung imbis na yung t in years ay it's just the number of years, imumultiply natin siya kung ilang compounding periods yung nagkaroon. So if the interest is awarded quarterly, hahatiin natin sa 4 yung rate, pero mumultiply natin sa 4 yung beses na binibigay siya sa'yo. So this is our formula for compound interest. Again, total amount is the principal times 1 plus the rate over the number of compounding periods raised to n times the number of years. For the second example, let's modify yung earlier problem natin. It's still 10,000 pesos. It's still an interest rate of 7%, but we'll have different compounding periods. So let's compute for the amount in 6 years if the interest is compounded quarterly, monthly, and daily. For the first case, the total amount is equal to the principal times 1 plus the rate over 4, kasi there are 4 compounding periods in 1 year, times 4 times t. Substituting our values, so in 6 years, a of 6, this will be 10,000 times 1 plus 7% divided by 4 times 4 times 6 years. And this is equal to 10,000 times 1.0175 raised to 24, or 15,164 pesos and 43 centavos. If we compare that with our initial answer na 15,000 pesos and 15,007 pesos, mas malaki to ng 150 plus pesos. What are we seeing? I think we're seeing na the more compounding periods you have, medyo tumataas yung magiging total amount natin. So, ibig sabihin ba nun, pag tinaas natin ng tinaas yung compounding period, para magiging unlimited yung interest rate natin? Well, we'll see. Tingnan natin if we compound monthly. So, 12 compounding periods. So, for the second case, the formula will be the total amount is equal to the principal times 1 plus r over 12 naman, kasi there are 12 compounding periods. In 6 years, this will be equal to 10,000 times 1 plus 0.07 over 12 raised to 12 times t. And compute lang natin siya. And you can use a calculator and you can see that this is equal to 15,201.05. So, mas malaki yung total amount kung monthly yung compounding, same interest rate, 7, compared sa quarterly, at yung quarterly, mas malaki kung compare natin sa annual. So, what do we expect kung daily natin siya i-compound? So, for the third case, same formula, but this time the rate will be divided by 365. And there are now 365 compounding periods, kaya multiply natin yung t by 365. Substituting our values, 6 years, 10,000 for the principal, rate is 7%. And plugging this into a calculator, we'll have 15,219 pesos yung total amount natin if we compound daily. Note lang, walang bangkong nagko-compound ng daily as far as I know. Hindi siya talaga practice. So this is just, for the purposes of mathematics and for a deeper understanding. But practically, makikita nyo siguro quarterly and monthly. Yun yung common for savings accounts. Now, if you've been paying attention dun sa example, you might think, abay mo, lumalaki pala yung ma-earn ko na interest pag dumadama yung compounding periods. So what if we compounded weekly? What if we compounded daily? What if we compounded more? sobrang lalaki ba yung interest rate na meron ako? So, tignan natin to, no? Ano ba mangyayari pag dinamihan natin yung compounding periods? So, yung 1 plus r over n multiplied to n times t, let's simplify that multiplier by setting our principal, our rate, and the number of years to 1. So, focus lang tayo dun sa n, yung compounding period. So, if the principal rate and yung years ay 1, so this would be 1 times 1 plus 1 over n raised to n. If we start to compound weekly, yung 1 plus 1 over 52 raised to 52, so ito yung n, yun yung n, this is approximately 2.69. Pag dinamihan mo yung compounding periods to daily, this expression will be equal to this, 2.7145, and so on. Now, as we proceed to more and more compounding periods by making the period shorter and shorter, so hourly, walang ganito ha, walang mag-o-offer nito. This is just a mathematical exploration. Nakita natin, lumalaki naman talaga yung rate. But even if you reach the point na every second na yung compounding mo, wala nang ganyan. Parang halos wala rin naman siyang difference dun sa every minute. So, yung daily sa weekly, ang liit lang nung difference. But from hourly to daily, nasa third decimal place na yung difference. Moving from minute to second, halos wala na siyang major na difference. Ngayon, ito yung curious. Saan papalapit ng papalapit yung value na nakikita natin? Saan natin na-encounter yung 2.71828? This is Euler's number. Diniscuss natin to nung nag-discuss tayo ng natural logarithms. Siya yung base ng natural logarithms. Now, hindi ito yung reason, no, kung bakit siya tinawag na Euler's number. Iba yung approach ni Leonard Euler, kaya niya na-generate tong constant na to. But it's interesting that it comes up pag nagpupunta tayo sa ganitong expression, yung 1 plus 1 over n, tapos yung n raised to n, tapos papalapitin natin ng infinity yung n. In fact, Euler's number will pop up kung saan-saan na weird places when we are discussing different branches of mathematics. So ito yung first appearance niya dito. But this will not be the last time na lalabas siya. And the next time you see it, it's probably not even related to interest rates. So the idea that nagko-compound tayo every second, and if you go every millisecond, every nanosecond, you can imagine it as something na nag-grow all the time. Imbis na you wait for a certain amount of time, maglalagay ka ng dagdag, we could imagine it as something na nag-grow all the time, continuously. So it doesn't have to be money. It could be a population, could be a model of a bubble na unti-unting nag-expand. I don't know. We're just using yung idea ng interest rates. But if you imagine something na nag-grow continuously, then it's like we are setting the compounding periods to approach infinity. And we'll call that continuous growth. So let's look how we can derive another model, another function for a scenario na nag-grow lang continuously kung ano man yung ino-observe natin. Now we have seen kanina, no, nung tinignan natin yung compounding over smaller and smaller amounts of time, na hindi talaga tayo aabot ng parang infinite money by just having more compounding periods. Meron siyang tatamaan na numero, and that is Euler's number. Even if you compound continuously, like every second, every millisecond, every nanosecond, syempre walang gagawa nun, but yung implication ng mathematics, even if you go into smaller and smaller and smaller compounding periods, so parang dadamihan mo yung period by shortening the amount of time, hindi ka lalagpas dun sa Euler's number. And we represent that by using the limit expression. Now, ito, i-reintroduce sa atin to pagdating natin ng siguro grade 11. But we'll use it now. Ibig sabihin lang nito is that yung values ng x natin, papalapitin natin ang papalapitin sa infinity. So, si 1 plus 1 over x raised to x, pag yung x pinalaki mo ng pinalaki, lalapit ka ng lalapit sa Euler's number na e, which is yung 2.718281828 approximately. And what will you do with that information? So let's say na wala nga talagang mag-o-offer sa'yo ng continuous compounding, but there are many phenomena that you can model as a continuous growth. Yung hindi siya maghihintay ng 6 months bago mag-increase ng size. Parang at any given moment in time, nag-i-increase siya. So this could be, kunyari, ikaw, nag-grow ka exponentially. Wag yun. Kunyari, isang population ng sobrang daming mga organisms like bacteria or tao na titake mo on a global scale, hindi naman yan maghihintay ng 6 months bago mag-increase ng 1%. It's always growing. It's growing more or less continuously. So, in that case, pwede natin siyang i-model as a continuous compounding function. But kung babalik tayo sa investment, sa pera, yun muna yung starting model natin. The amount is principal times 1 plus rate over n raised to n over t. So, ang goal natin ay ma-rewrite to using Euler's number. So, first step ko ay isusulat ko yung r over n as 1 over n over r. So, equivalent naman sila, di ba? And then, I will take note of this n over here. I will rewrite it in a special way. So, I'll rewrite it as n over r. Saan galing yung r? Well, niligay ko lang siya. So, hindi siya dapat nandun. So, para ma-cancel siya, maglalagay ako ng isa pang r. So, notice that itong r na to at itong r na to, they will cancel each other out. But now, take a look at the expression inside the square brackets. Is 1 plus 1 over something raised to something. So, yun yung x natin dito. So, kung magko-compound tayo continuously, which means yung n natin, the number of compounding periods, palaki ng palaki. The period itself will liliit. Kasi liliit yung amount of time. But the number of periods, lalaki ng lalaki, and we'll let it approach infinity, then yung n over r, mag-approach siyang infinity. Kasi r is just a value. So, kahit kung mag-approach ng infinity, numerator niya, then the whole expression will approach infinity. Which will imply that the expression inside the square brackets, mag-approach siya ng e. Kasi yun yung nakita natin dito. So, we'll just replace the whole square bracket thing with e. And we'll have the continuous compounding formula, which is also the formula we'll use for continuous growth, na the total amount is equal to the principal times e raised to the rate times time. And so we arrive at this formula. So some textbooks, itong formula na to, ito daw yung formula for continuous compounding. Walang ganun in reality. But it's a convenient way of referring to it kasi dinerive natin siya from the idea of compounded interest. Tapos i-connect natin sa continuous exponential growth. So, some books would refer to this as the continuous compounding formula. Now, let's take a look kung paano natin pwedeng i-apply itong formula for continuous compounding, but it's actually the same formula for continuous growth, to applications na meron talagang nag-grow.